Hi, Leanne. How you doing? My name is Roger, and I'm answering your question on the seek help at Wyzant. And this is a combination of physics question, which contains work, understanding, and some equations of motion too. Okay, so you got a kind of a box here. This box weighs 15 pounds, and I can denote it by this arrow here down. You also have a force of 10 pounds, which is acting at 300 degrees to the horizontal. So if we can say that this is the horizontal here, which is x axis, and this is the vertical y axis, then this angle will act somewhere, this force will act at this angle of 300 to horizontal. So when we say 300, which means that we're measuring counterclockwise to be positive in a circle. So if we go around like this, up to where the horizontal is, that will give you about 300 degrees. Now, knowing that the entire circle is 60 degrees, then this makes this angle 60 degrees. Sorry, knowing the entire circle is 360 degrees, this makes this angle 60 degrees. So if we project this up, make this, project this force up, like that, okay? And we try to find the components of this force. Let's just use this as a horizontal here. If this is 60 degrees, then this will be 60 degrees because it's what? Opposite angles, okay? And we know that the measure of the angle from x to y is 90, therefore makes this angle 30 degrees. Okay? If this is 30, then this is 60. Okay. So what I did is I projected the force up in order to kind of simplify the calculations a little bit. So if you notice in this problem, they give you the box, and they said the box, after the force is applied, moves a distance of 5 feet. So here's the box again. And it moves a distance of 5 feet from where it started. So let's just say this is the box. This will be, again, its center of gravity, and that is its weight, 15 pounds. So starting from the centroid of the box to the centroid of the box, this distance is 5 feet. The distance that it moves is 5 feet. So when we start to solve a problem like this, we have to see what we have. Well, we have the distance, which is called a d. Distance is 5 feet. Now this force here, as you can see, is 10 pounds, but it's at an angle of 60 degrees. Therefore, we have to break this force into two components, one horizontal and one vertical. So the horizontal component will be along this line. And that horizontal component is going to be 10 pound cosine 60. Here will be 10 pound cosine 60. So what would be the vertical component? Well, the vertical component is right through here. Is going to be 10 pound sine 60. So this is a vertical component here. It's going to be 10 pound sine 60. So the question here is, what is the force that is going to move the box horizontally? Okay. What are the forces that will actually move the box horizontally? Does this vertical force cause the box to move horizontally? The answer is no. Does the weight of the box of 15 pounds move the box horizontally? The answer is no. The only thing that will move the box horizontally is this horizontal force, 10 pounds cosine 60, which is directed parallel to the line of movement, which is along the x-axis. Okay. So if any work is to be done on this box, it will be done by this force here. Okay. So now we know what the force is. It's 10 pound cosine 60. Well, cosine 60 is 0.5, so that will be 5 pounds. So it will be 10 pound times cosine 60, 10 pound times 0.5 give you 5 pounds. So the force that is moving the box or contributing to the movement of the box is 5 pounds. The next thing you're going to notice is that it doesn't say anything about friction here. It does not give you any friction coefficient or anything like that. When that is the case, then it's considered to be a frictionless surface, which means that the force of friction, I call that F sub F, is equal to 0. Had the force of friction been present, then the force of friction will be a force which is basically in the reverse direction of the line of movement. So if this is the force is moving at 5 pounds, this will be the force of friction. It will be like this, in this direction. Okay. But since there is no friction coefficient given in the problem, and it's assumption that it's a frictionless surface, then that force is 0. Okay. Your first question is, what is the work done on this box? Well, the work is simply can be done by this formula: force times distance. Okay. You've seen this before. So what is the force? Well, the force is that horizontal force that we already found to be 5 pound force. Oh, by the way, I want to differentiate between that. I want to just make sure that I put 5 pound force here, because I will be using pound force and pound mass, and I don't want that to be confused. Okay, so the work is 5 pound force times the distance. Now, what is the distance? 5 feet. That's how much the box moved. So 5 feet, and that will give you 25 foot-pound. Okay. £25 is the work done by this force on this box. So that is your, I think, question A, asking you what is the force what is the work done by the force. Okay. Now, question B is asking you what is the acceleration of the box as it moves from this position to this position. Okay. So as it moves from 0 to 5 feet. That's what the question is. So they want the acceleration. I call that acceleration A and put a question mark, and that's what they're looking for. So how do we find the acceleration? Well, we have to go to the Newton's second law of motion, which says that sum of all the forces on an object equal to its mass times its acceleration. Okay. So sum of the forces on the object that is causing the movement. Well, does this vertical force apply? It does not. Okay, because it does not cause a movement. It does not cause an acceleration. Neither would. Would this force cause an acceleration? Yes, it would. So basically, what the law says that sum of the forces, which is going to be only the 5-pound force in this case, 5-pound force, equal to the mass. Well, the mass is the 15-pound mass that is here. So that's 15-pound mass. Times the acceleration, A. Now, what should be the acceleration A? What unit should be? It should be, what would the acceleration unit should be? It should be in foot per second squared, right? So that's the acceleration unit. But look at this. If you divide pound force by pound mass, you're going to get confused here. You're going to say, oh, this is kind of unitless. Well, it's not, okay? Because you have to realize that a pound force, a pound mass, I'm sorry, a pound, 1 pound mass is equal to 1 pound force times second squared per foot. Okay. That is the thing. When you divide then pound mass by, when you divide pound force by pound mass, you're going to get foot per second squared. Okay, so this is just the difference. So the acceleration is going to be 5 pound force divided by 15. I'm running out of room here. I'll write that down here. I'll write that up here. A is going to be 5-pound force divided by 15-pound force times second squared per foot. And A is going to be, so this one, this cancels out, and foot goes up, so you get foot per second squared. So 5 divided by 15 is 0.33 foot per second squared. Okay, and that is your question B. Okay, I'm going to start a different board here because we're running out of room, and I want to be as clear as I could. So in question C is asking you, what is the time required to move the box from rest to the position where it's 5 feet away? Okay, so this is more like a equation of motion question. So we know the general equation of motion is x equal 1/2 a t squared plus v0 t v0 t plus x naught. So what are v0 and x naught? Well, v0 is the initial velocity of the box. Well, when it was at rest, the initial velocity was 0. So v is 0. And what was the initial distance when it was at rest? It was also 0. So v0 and x0 are both zeros. These are zeros. The only thing left in this equation is x equal, which is x is the final distance, equal to 1/2 a times t squared. So we know what x is. X is 5 feet, equal to 1/2. We know what a is. Let's go back to board 1. What was a? 0.33 feet per second squared. So 0.33 feet per second squared times t squared. So let's do this calculation. 5 times 2 is 10 divided by 0.33. I got 30.3 what? Second squared, right? T squared is equal to 30.3 second squared. Let's see, can units, foot and foot cancel out, and this second square goes up. Yeah, okay. And so t is the square root of that value. T is square root of 0.33. We'll take that square root. I got plus or minus 5.5 seconds. Well, when we're working with time, there's nothing called negative time. There's negative distance. There's negative direction of load, but there's no negative time. So that means the negative answer is out, and t is equal to 5.5 seconds. Okay. Now we come to D. In D, he's asking you, what is the final velocity when the box had moved at that point? What was the final velocity? Okay. So we also use the equations of motion, and there's a famous equation there. I don't know if you remember it, but here it is. It's called V final squared minus V initial squared equal to 2ax. And that is a kind of the equation that uses is not dependent on time. Time is not a factor here. So if you know the acceleration and you know the distance and you know the initial velocity, you can find the final velocity. Okay, so we know that V naught is 0, so that makes this 0. Therefore, V final squared is equal to 2. A is 0.33 foot per second squared times x. X is 5 feet. So multiply all of that together. And just write it down here. I want to write it in feet. So when you multiply 2 times 0.33 feet per second squared times 5 feet, you're going to get 2 times 0.33 times 5. You get 3.3 3.3 you're going to get 3.3. I have to write with this pen, I tell you. Foot per second squared, foot squared per second squared. So V final is the square root of that value. So square root of 3.3, I got 1.816. I'm going to call it 1.82 foot per second. And that is your final answer for D. And that's it. Thank you very much. Have a good day. Bye.